Hi guys, how you doing? Hope you're well. So the plan with this video is to use a Zener diode to control the voltage at which point the relay triggers and switches to the other circuit. So the ultimate goal is to basically make a solar panel, a battery with a relay in between them. And then I want it so that when the relay reaches a set voltage, it disconnects the solar panel and the battery. So the way that that's going to work is that if I've got a 12-volt battery, then I want it so that when the voltage of the battery reaches 12 volts, then the solar panel gets disconnected, then it stops charging the battery. Then when it drops below 12 volts, the solar panel gets reconnected again, and then therefore it starts charging the battery again. So that's the plan. That's a simple one-stage charger. The next stage will be to use 2 set levels, and we'll do that in the upcoming video. First, let's see if I can get the Zener diode. So I've got a 5.1 volt Zener diode and a 12 volt Zener diode. Let's see if I can use these to control the voltage at which point the relay triggers. So I think the first stage here is let's figure out what voltage this relay triggers at. I'm going to guess it's going to be 2.5 volts, even though on the relay there you can see it says 4.5 volts, but I'm guessing it triggered at 2.5 volts. Cool. So here's our circuit. You can see the green LEDs on. So I've got my batteries here, 6 volts coming in. So if I move this out of the way, so you can see better. And then I've got positive, negative on the rails here, positive coming to here, going to the power pin on my relay, and then I've got my variable voltage that I'm going to apply here. Currently there's no voltage there, and then so currently you can see this green wire is the one that's being powered and this blue wire is not being powered. So if I turn on my power supply now, currently at 0 volts, as I turn it up we'll find out the voltage that the relay is currently triggering at. So I'm increasing the voltage now. We're at 2.2 volts, hasn't triggered yet. 2.5, boom, there you go. And then if I keep going up higher, so 8.3 volts there, no difference. Cool. So currently triggered at 2.5 volts. So let's turn that back off, back to 0. All right, now what I want to do is I want it so that when I apply, for example, this 5-volt relay, this 5-volt Zener diode, I want the relay to trigger at 5.1 volts instead of 2.5 volts. Let's see if I can do that. Believe it or not, something as simple as what I just explained, this is now 5 hours later. And the answer is you can and you can't. Cool. Okay, so let's talk about the 5.1 volt Zener diode, right? So what I did was, let's just first turn this on. We'll take the 5.1 volt Zener diode. Okay, so I expected this to just work simply, right? I take the Zener diode, right? I just make sure it's the right way. Yeah, take it off the positive from the relay, connect it in here, and then stick the variable power supply in here. Turn on the power supply, currently at 0 volts, start cranking it up, and I'm just expecting once I get to 5 volts, it's going to switch over. I'm now at 6 volts, so just to show you, let's show you guys. So 7.2 volts, right, and it still hasn't switched over. There you go. Like what? Why? Why did it do that? Why is it doing that? Alright, let's go back down. Okay, switch back over. Let's go back up now. And so it usually switches over when it gets to 50 milliamps. So crank it up a bit more. Should turn over now. There you go. And so the Zener diode gets so hot. Basically, these Zener diodes, they're just not suitable, I think, for these low currents. But I also don't really understand it because at the same time the Zener diode is heating up. So some people say stick a current limiting resistor in there. I don't know. For whatever reason, it just doesn't work, and it's at 8.1 volts. And so you basically got to think, okay, how can I drop the voltage down? And I thought I was getting a bit crazy, so I said to myself, look, maybe I'm putting the Zener diode in backwards. Let's turn it around. So there, at 3.5 volts, it starts conducting. So here now, right, the Zener diode is just allowing, it's just in the position to just allow, it's forward bias, right? So it's literally just letting current through anyways. The only difference is that there's a 0.7 volt drop across it. but it makes such a big difference in the voltage. 3.4 volts versus the 8 volts all the way around. I don't get it. And it's the exact same thing with the 12 volts as well. Let's take this out. We go to 12 volt one. And I checked online, and basically a lot of people have this same issue whereby their Zener diodes heating up, and I think it just requires like some sort of complex circuit, but this can't be done. You can't control the relay with a Zener diode. I'm not sure if it's got something to do with the current or whatever. So this is a 12 volt Zener diode. So as I crank it up, so at 12.2 now we're expecting current to now be allowed to flow, right? And we're expecting that the relay is going to switch over, right? And let's just keep going. 12.2. So now you can see the current going. So now it's pretty much ready to start to trigger the relay now. Right, 16.2 volts. There we go, 17.5 volts. And I wish you guys could touch that Zener diode. I wish you could touch it. Ah, it's so hot, man. And then it starts to smoke. This is a brand new Zener diode that I just pulled out the packet. I've burnt a bunch of these tonight. And I mean, there's just, I don't know, there's no solution. Look, you know, 17.6 volts. I mean, there is a solution, but there's no solution to, it smells like some food, but it's not. It's the Zener diode. The relay is not hot at all, but the Zener diode is boiling. And yeah, I mean, there's no solution here now in order to get the Zener diodes working. They just don't. I'm not sure why. I kind of, again, like I said, I kind of get it, but I don't. So what I did was I tried it out. Have a look here. I tried it out with no Zener diode, just a resistor, and I tested out different values. And so when I tried out 100 ohms, I was getting 8.4 volts trigger voltage. So let's just test it out now myself. So I'll show you what I mean. So I'll take, I don't have my 100 ohm resistor here, but we'll go with the 160, which works, right? So 160 ohms. I'll show you the 150 actually, which triggers at 11.5. So I've got a 150 ohm resistor here. All I'm going to do is just put it in place of the Zener diode, right? So just go to 0 volts. And then, cool, that's in there. All right, so now I'm expecting at 150 ohms. I don't know the calculations for this, but this is what I figured out by trial and error. So at 11.5 volts now, this should trigger the relay. 7 volts, 8 volts, 11. There you go. So 11.6 volts. And that switched over. So now what I can do is, if I want it so that it triggers at 12 volts, just add an extra 10 ohms on there. So I just take a 10 ohm resistor, add it in series with that resistor, the 150 ohm one. Stick that in now. Alright, and then now we're expecting 12.1 volts. Yay! Let's just go back to just show you. Again, there we go. Okay, so 12. Yay, 12.1 volts. And it switches over. So I'm guessing I need to basically I need to figure out what voltage I want my battery to be at, and then I don't know the calculation for it, but basically I could use trial and error to figure out what resistance value I need in order to be able to trip and trigger the relay at that voltage value. I wish I knew and understood how to actually go about calculating this, but I really don't. Just to show you, look, everything is still working. When I connect it directly to the relay at 2.5 volts, it trips. Let's go to 2. And so you can see it works more than fine. But when you add the Zener diode in there, it just goes crazy. And so I'm not really sure how to go about I'm not really sure how to go about designing this. I don't know if this is particularly useful. I can move on to other circuits, but I would like to figure out how do you control the voltage of this relay without just guessworking using resistors. If you know, leave a comment down below, and hopefully by the time you comment I would have figured it out. But I mean, I'm pretty much ready at this point to move on from relays now and just exclude that from my final year project, and then just move on to, like, it's a bit crazy, but there's like more complex circuits that I think is better for me to start with. And when I spoke to my supervisor today, he did recommend that, you know, there was a comparator circuit using a transistor, a comparator, and a relay and a voltage divider in order to detect the voltage at the battery. Now, that's going to be super complex for me, but I'm going to give it a go, because this simple stuff, although in theory I don't see why it wouldn't work, in practice it does not work. And yeah, these lovely Zener diodes, they don't work as they say they're supposed to in the book. And I'm not sure, you know, like how I would add a current limiting resistor. I did try to add resistors in front and behind with Zener diodes. Unfortunately, no success there. What I'll do is I'll just show you here, right? So I don't know if this is the 5.1 volt one. I'll get a new one out, right? So, all right, 5.1 volt Zener diode. Okay, connected that to our relay, and then now 150 ohm resistor going in front of it. And now connect that. So I'm expecting, you can see already, look, this is supposed to allow current to go at 5.1 volts. There's no current right now. Go up. 5.1 volts, nothing. 7 volts. So we're starting to get some current now. Still nothing. Still nothing. Still nothing. And so what I actually found is that the resistor, you're going to trip soon. There we go. 17.7 volts. I found that the resistor actually increases the trigger voltage. Is this hot? Kind of. Alright, so let's check it without the resistor. So that was at 18 volts, right? And there you can see, look, it started already. There you go. Like as we mentioned, on 8 volts. So adding a resistor in series with the Zener diode massively increases the trigger voltage. So I actually also then added diodes in order to try and drop the voltage from the power supply before it reached the Zener diode, and again that still didn't work. So I'm lost, I'm confused, and I've got nothing. I've got nothing to show for it other than I can combine resistance values by guessing, by trial and error, in order to figure out the voltage that I need. I know most people have a voltage divider network and then they use a variable potentiometer as well. That's probably what I'm going to end up doing. But I'm going to go and do some studying. I'm going to read the Art of Electronics book. And yeah, I'll get back to you guys in the next video. Don't know where I'm going from here, but we'll see. Take care.